almost forgot about you at home. All right. So, for number one, like what methods, what did you guys do to come up with the warm-up question here for number one? Did anyone actually solve it like algebraically, like use like the algebra steps or just guess and checks? I think you could probably figure out pretty easily. Yeah.
I multiplied both sides by 2.
Yeah, a great way to start with this is get rid of that fraction. Most of us would not say like, hey, fractions are my favorite. Like, I mean, even as a math teacher, I gather that that's not the case for most people. So what we've suggested is let's get rid of that 2. So you can multiply each side by 2. The only thing with this that I see a ton of mistakes with is for whatever reason, students, well, I think just because they've learned to distribute, they want to distribute and divide, and you don't do that. If you're dividing by 2 and multiplying by 2, they're inverses of each other. They just cancel out. You don't have to distribute that 2 in. So I'm left with x minus 4 here, and then just equals 20. And some of you guys might have kind of done this in your head anyway, like that just might have made sense to you to kind of work through that in your head. I know some of you guys, I saw just the answer, and it's okay. And then here to solve this, pretty straightforward. Now we're just going to add 4. So x ends up being 24. And if you go back and check that 24 minus 4 is 20, divided by 2 is 10, seems logical. All right. Now, a problem like that is kind of, we'll see that in a little bit with this distance and midpoint we're working on today. It has to do with the midpoint of a line. All right, this next one, evaluate. How do you guys decide to evaluate this? Like what rules tell you what to do first? Got some rules for this. Someone a long time ago, way before I was around, came up with a set of rules. What do we call those rules? Anyone know? Got it? Anyone know the name of the rules? You might not know like the actual name, but you might know PEMDAS. Order of operations tells us how to do this thing. I can't just say like, I want to square everything right now, or I want to add things right now. I have to follow the rules. So I have to do inside the parentheses first. So I'm going to do that. So negative 5 and 2 is going to be a negative 3. Square it. 0 minus a negative 4 becomes plus 4, right? 0 plus 4. So that's already looking a little bit better. Now again, I can't just say, well, I'd rather add than do exponents right now. I can't just choose to go in whatever order I want. Just like if I gave you guys directions to my house, you wouldn't just want to be like, she said left and then right, I'm going to go right and left. Like, it'd be crazy. You have to follow those directions. So same idea with order operations. So negative 3 squared is how much? Negative 3 squared multiplied by itself, 9. It's a positive 9. 4 squared is 16. We add them, we get 25. Now, again, if you got this wrong, don't think like, oh my gosh, she's going to kick me out of geometry class. I put you back in algebra, Will. But so I'm not like kicking you out. But the reason we're doing this as a warm up is just to remind you guys, like things we learned in algebra. These two ideas are going to be used in what we're doing today. So once we review them, I think a lot of you guys are like, oh yeah, I totally forgot about those order of operations. Because it's not like all summer you were hanging out with your friends talking about the order of operations. And if you are, you're like the coolest friend group ever. But I mean, I'm assuming that's not the case. Because I did not talk about order of operations over the summer, and I'm a math geek. So what we're working on today is something called, or we're finding the distance between 2 points and also the midpoint of 2 points. So the distance between 2 points, I think you guys are probably comfortable with the idea that how far is this point from the next? Now, that doesn't mean we're necessarily measuring, like you're not taking a ruler and doing that. Well, we are going to do that kind of as activity today. But It's how far apart they are, like in terms of like units, on like a graph or something like that, or the midpoint. And let's talk about what a midpoint is. Any guesses? What's the midpoint? What do you guys think? Point exactly in between the 2 points, like the halfway point. So now, a midpoint is always going to be on the line between those 2 points. So it's collinear with the endpoints. So that's important to be aware of. So if you and your friends lived on different ends of town and you said we're going to meet halfway, it would be the exact middle. I would meet a friend to run in Grafton. I live in Grafton, and we'd run each from our house and meet. And it was always funny because we'd say who was like faster that day. If we got closer to the other one's house, like as we met on Highway 60 in Grafton, like so to tell if she was going to be speedy that day if she beat me to our normal midpoint. I'll show you guys how that looks. So M is our midpoint. And I'm going to use those little tick marks we talked about yesterday. That if M is the midpoint, that means this distance and this distance would be the same. The halfway point between those two, that means they both went the same distance to get there. So it's like fair on each side. The next thing we're going to talk about is really, really similar to a midpoint. It's just a midpoint is a point. The fact that it says it's a point tells you that it has to be a dot. The next thing we're going to talk about is segment bisector. A segment bisector is basically a midpoint that doesn't necessarily have to be a point. It could be a line, it could be a ray, it could be a lot of other things that cuts it into 2 equal pieces. So a segment bisector could be a point, a line, a ray, a line segment. I don't think there's anything else. Even a plane. And all of those things take the segment and cut it into 2 equal parts. So all of these intersect a segment at its midpoint. And so I'll show you guys a little example of what that would look like, and then we'll actually do some problems involving that. So using one tick mark, I'm using two, and I'll explain why that is in a second. If you want to draw that picture, then I'll explain. So I'm using the two tick marks this time because I want to show you guys you can use two as long as you're showing that those two are the same. But what this is also showing is if these two drawings were on the same piece of paper or like in the same problem, this is different than so CM is different than AM. So the fact that this has two marks versus that has one, it's just kind of showing that they're not all the same length. So it's kind of just a notation thing. I just want to show you guys can use two, you could use three. Yeah, it doesn't really matter. So first of all, what's CD? What kind of shape is CD? What do we call that? What do we call CD, you guys? I heard it. Line segment. How about MN? That's a ray. Yeah. So the ray MN is a bisector. So MN bisects CD. So we call that a segment bisector. So that ray MN bisects CD. That makes those two equal pieces there. So they'll use that, and M is still a midpoint. So you can call M a midpoint, but that ray is what bisects that line, that segment, sorry. All right, we'll do a couple of examples, and then I do want to get us outside to do a little activity. I kind of keep forgetting the grass is wet in the morning, so we might use the sidewalks. But another group out there, so much. Hopefully they'll be done by the camera. Okay. So M is the midpoint of PQ. Find the length of PM. So M is the midpoint of PQ. Find the length of PM. So if we know it's the midpoint, that means those two smaller segments are what? Equal. Or the geometry word congruent. I'm fine with you saying equal, but geometry would say congruent. Those two are the same. So how are we going to set this up? What are we going to do? Kind of similar to what we did yesterday. Yeah, Leah? Yeah, we can just set these two equal, and then we can solve them. So 5x minus 2 needs to equal 3x plus 8. I don't know what they add up to, nor do I need to know, because I know they're the same as one another. So I'm able to set them equal. So I like moving the smaller variable first, so I'm going to move this 3x over. Once I'm there, move that 2. And then I can divide by 2 to find 5. Now, is that my answer? Is that what they're asking for? No, they said find the length of PM. I found out x is 5. That means x is 5 in the whole problem. So then I can use that. Again, we did this yesterday. I can use that just to put that back in to find just PM. They're not asking about PQ. They're not asking about MQ. I mean, obviously you can find all that, but all they care about now is PM. What's the distance that between those 2 points? It's going to be 5 times 5 minus 2. So PM is going to be 23. The next one, really similar. Now instead of being just having a midpoint, it's just bisected. So it says identify the segment bisector. So what would we call the segment bisector? So if I said identify the smartest person in this class, that person should tell me what the segment bisector is. What's the segment bisector here? the segment bisector? The line. The what? MR, what kind of shape is it? It's a ring. So the segment bisector is MR. So ray MR is our segment bisector. So they ask you about that. So when I do these examples, if you guys are going to see that this is really similar to a homework question. Like I'm not just doing these because I think they'd be fun to do right now. This is really similar to a homework question, so it should align with that. So they might ask you to find the segment bisector. That's kind of what they're asking you to do. Then they ask you to find PQ. So this becomes a really similar question to that last one. So if you want to take a minute to do that, I'll kind of come around and check and see if I can help you guys with anything. I believe it's a decimal this time, so don't let that throw you off too much. I think the X value ends up being a decimal. Not a very nice one either, I don't think. Okay, you might need a calculator. You can do this in your head, I'm impressed, but you might want a calculator. So once you have that value, you're going to want to put it back in to find the value of, in this case, they're asking for PQ. Here, let's do it. And if you haven't started, bring your calculator. I know we haven't used the last couple of days much. I just ask you guys try to start having it with you. If it just goes in your laptop case, that would be great. Most days we will use it. I prefer you guys not use your phone. So if that's all you have today, it's okay. But other days I'm going to ask you guys don't have your phones out. Some of you guys are doing long division. I'm impressed. Old school. But then trying to multiply that back through might be a little bit of pain. And if you left as a fraction, that's fine. If you worked with it as a fraction, perfectly fine. Okay, I'm going to start working through it up here. So if you guys are stuck, we're setting these to equal again. I like moving the smaller x, so I'm moving that 2x over. So for my x value, I got 18 over 7. Dividing by 7 is not a nice number. I know a lot of decimals off the top of my head. Anything with a 7, I'm probably not going to know because it's like some sort of like crazy non-repeating decimal. It doesn't like stop after 2 decimal places. So it's like 2.57, is that right? Something like that. So 18 over 7. Once I have that, then I need to substitute that in. So about 2.57. I have to find PQ. But PQ is this whole thing. So I can either find them each individually, I can add them together right now and like put it in that way. I can, but if I find them each, or just find one of them and just double it, so I can do like 5 times the 18 over 7 minus 7, and then double that. So that's probably what I'm going to end up doing. So I end up like 11.7 when I do that. Or no, sorry, 5.86. So that's one of these. And then here's another one that's 5.86. So then when I put those two together, PQ ends up being 11.7. Is that about what you guys got as well? Yeah. So about 11.7. All right, questions at all? All right, so I think I might wait a little bit longer just because there's people out there right now. If they don't leave after the next example, then we'll go on. Take over, but it looks like there's a lot of them. So the next thing we're going to be talking about is something called distance formula. So how to find the distance between 2 points on a coordinate plane. So this happens to be something that comes up a lot as you move forward in math, like distance formula is used all over the place beyond geometry. You probably have seen it before. I know it's like a pre-algebra topic, but it's not one that like they expect that you're like 100% on. So distance formula is used, but maybe you didn't, like you learned it, but you're kind of like, a little iffy on it still. So we want to find the distance between these 2 points, and they give us the distance formula here. Now the distance formula is something I'm going to eventually want you to memorize. So I'm going to want you guys to learn the distance formula and know it for a test. Obviously today is not test day, so you don't have to know it today, but maybe you kind of know it a little bit already. So the D is obviously distance here. What do you think the X's and Y's mean? Like what is that telling us? What do we know about X's and Y's? Where do those come from? Where are we going to get those? Looking at that first example, yeah, Will?
The like the -4 and 1 and then
Yeah, what's -4 and 1? What would those stand for?
actually.
Yeah, there's an X and Y. And I actually happen to have another one there. So they give us a couple coordinate points. So just like they, you guys are my students, they put a bunch of students in the room, and you guys are all my students. Well, they give you guys names. So I'm not just like, hey, students. You get names. Well, they're not very unique in their names in math. They just give numbers. So since this is our first point, we're just going to call it x1, y1. Since this is our second point, x2, y2. It's just the first and last name needs to go together. So x1 and y1 have to be together. If you mix that up, like if you put x1 with y2, it's going to be a mess. So you don't want to do that. So it's just telling you this is my first x and first y, second y and second x. So then we're going to put that all into the formula. So we're substituting this all into this big formula. And what's really helpful, and I know I've seen like Ms. Miller do this with her students when she's like giving some help here, is kind of leave a little bit of space there. Like every time the problem's going to look like this. Distance formula is going to have this shape to it. It's going to have this set of points here, or this like kind of outline. But in the formula, it's asking me to subtract the x's, x2 minus x1. So I'm taking this and subtracting that. And I have to go in the same order each time. So if I decide to go this way, I have to subtract both of them that way. If I want to subtract the other way, I have to be consistent. So I'm going to do 3 minus a -4. We'll talk about that double negative there in a second. And then we're going to do the y2 minus y1. So I should go the same direction. -2 minus 1. Now I'm hoping this problem looks a lot like our warm-up question. The reason why we did our warm-up question is to practice this kind of idea. So again, I have to do the parentheses first. So 3 minus a -4 really just becomes 3 plus 4. And you might have just done that and called it 7. So this is going to be 7 squared plus -3 squared, -2 minus 1. So still have the square root there. So 7 squared is 49. -3 squared is 9. Notice they become positive. That's not like a magic trick that's supposed to happen. 49 and 9 is 58. Now, 58 is not a nice number, bless you. So we're really happy that we have our calculators because if you know the square root of 50 off the top of your head, you're strange. Oh, look at that. No, you're okay. Okay. Oh. Okay. 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 Thanks. Okay. Bye. All right. So square root of 58, you're gonna want to get your calculator out. Now, if you know this off the top of your head, like you're some sort of like math wizard. Because I don't know that off the top of my head. I know it's in between 7 and 8, but that's about it. So I need my trusty answer key. So it's like 7.62. It says round to the hundredths place, which is 2 decimal places. So 7.62. So an approximate value there. All right. So I want you guys, if you have some space, maybe on the bottom of the page, can you guys take a minute to use these same 2 points, or these next 2 points, and do the distance formula? So I want you on the bottom of the page, so kind of ignore the directions here. So take these columns, these 2, and put them maybe on the bottom of the page, and try the distance formula with those 2. I just want you guys to try distance formula one more time. Yeah, each should get up on score sheet, and they're all on there. Yeah. Yeah, and I asked the kids how they are. They, they hear, and they just fine. So they seem like they're going good. That was like my first attendance question was like, can you even hear me? Like, so again, guys, I want you guys to try distance formula for these 2 points. So the same formula we just did, and then we'll take a break. Sorry, I'm promising a break. It's only breaks, but if I'm a serious person, you see all day. All right.
Hopefully he doesn't get us around.
Throughout these guys. Yeah, doesn't work very good. Sorry, I'm moving you around and you're probably dizzy now. Yeah. Feel like on a roller coaster. Right.
Yeah. Oh, now they're gonna get really sad.
Sorry. Driving you all over the place. All right. So guys, I'm gonna work through the problem on the board over here. So again, you're taking the x's and subtracting them. So negative 14 minus 8. Now, if you chose the y's first, it's going to be perfectly fine. And then 12 minus a negative 6. So negative 14 minus 8 is a negative 22. And 12 minus a negative 6 is a positive 18. So what you guys got as well? There's some big numbers here. So again, calculators are really helpful because 22 squared or 18 squared is not the nicest numbers to work with if you don't have a calculator handy. And then you have to add them and take the square root. So I got 484 plus 324. So I end up with 808. So if you guys got two? Yeah, okay. See, a lot of people still writing. It's okay if you made a mistake somewhere in there. There's a lot of places to make mistakes. So we end up with 28.4. Oh, sorry, 4.3. We go to two decimal places. 28.43. You went wrong? Did you figure out where you went wrong? Yeah. Okay, I'm gonna pause you here for a second.